So this is your moment, brother.
Thank you so much. I'm very happy to see you all here. I reckon you all are a bit tired from a day full of tech talks, so we'll try to have some fun. I'll be talking about those guys over the internet. Some of you are absolutely in love with this, and some of you have all the reasons to hate them. That's robots, of course. My name is George, and I'm managing the product named Bot Protection for Curator Labs. Here's me on closing the snowboarding season this year with no bone fractures. Therefore, I look very happy here. And detecting and studying bots was originally my hobby. I have a background in DDoS mitigation, been doing that for a lot of time, and originally I didn't mean it to be serious, but as the problem itself grew bigger and became obvious, it became my profession. 2 years ago, we launched this product, and over these 2 years, we were able to collect some interesting stats and observations, which I'll be happy to share with you today. And first of all, I'd like to ask you for any guesses. How do you think, how huge is the artificially generated traffic in the internet? What is the share of bot-generated traffic now? 20%, 40%, 60%, 90%? Okay, 50%. Yeah, well, that's more optimistic. Any other guesses? Okay, 70. Well, probably all of these answers are correct in some way, judging by the data set you use to analyze. From what we've seen with our customers recently, what we saw last year, the distribution of the traffic looked like this. So it's more like 40% artificially generated traffic, 60. The humans are still prevalent here. And when we're talking about bots, by the way, some of the vendors are less optimistic. For example, if you listen to Imperva guys, they are leaning more into 50-50. Probably they are more scrupulous at catching bots than we are. I don't know. But anyway, when we're talking about bots, we can slice them into two categories: the good, the wanted ones, and the unwanted ones. When we're talking about good bots, we mostly use we mostly imply the search engine crawlers, of course, the traffic monitoring tools, the uptime monitors, SEO optimization, all of this stuff. These guys are just here to do their jobs. They make themselves well-known and easily recognizable by the server side by having distinctive user agents, some other headers that they can be easily tracked by. Well, they have to make themselves recognizable for that task. Some of the vendors, like Yandex and Google, also publish the guidelines on how to check the validity of their bots and their requests by checking the DNS records and checking the IP subnetworks where it belongs to. For the unwanted bots, however, the situation is a bit different. The task they have to solve is quite the opposite. When good bots have to make themselves well-known, the bad bots have to look and behave like humans in order to achieve what they're trying to do. Grabbing the data, doing things like spamming, credential stuffing, brute force attacks, and so on. You have to blend in with the human crowd the server wants to serve in order to stay undetected, not raise any suspicions. So the task of human mimicking for scrapers and other types of bots is a crucial task for survival. They achieve it through different means, and sometimes they go a great length in order to imitate humans, and this usually costs money, real-world money, even with open source tools. And let's try to understand why data scraping is such an omnipotent and omnipresent thing, why people are ready to pay real money for doing these tasks. The roots of these problems can be shown by this elementary school grade formula that I'm trying to explain here. Working with scraping, you usually work with data sets. You have a number of uniform data points which are further to be processed and analyzed by some third party. For example, if you're selling this public data, you need to have a nice and tidy spreadsheet with all the values line up nicely. You have the given time frame in which you need to collect all of your data. And you have to allocate some server resources in order to do this task. This can be further subdivided. Let's see why. So your data set is the number of devices you're trying to imitate, the human-operated devices, the request rate that each of these devices is doing towards the server, and your time frame. Let's say at some of the examples of data scraping, probably the most popular ones. You can sift slowly through social media posts for marketing research, a big data set, but you have a lot of time to do that. You can see the stock residue for goods at online stores, a very important task for scrapers, to track how many goods of certain type are still there, available in stock. This data is updated more often, usually per minute, but the data set is smaller. And of course, a very fast-changing world of live bets, stock prices. The API updates the data per each couple of seconds, and even with small data set, you need to grab it very fast. You actually need to be faster than the other guy doing the same job to stay competitive, because the data consumers will buy it from you and not from the other guy. So you need to be faster than that. And this amounts to ludicrous amounts of requests per second you have to do as a data scraper. And of course, the obvious problem here is there isn't any server who will try to accept this request rate from a single user. Most likely you'll get blocked, your IP addresses will be blocked, and that'll be the end of it. Because no human user is doing 1 kill request per second, that's for sure. So you need to split up this load to different human-imitated devices, and usually the proxy IPs are used for this task. You need to lower the request rate for each of your scraping instances in order to be vaguely resembling a human, usually less than 1 request per second, and you need to run your scraping requests through a set of proxy IPs to mix them up, to rotate them, and to pass as different human-operated devices. The problem is if you use data center IPs or your any kind of cloud IPs, that will be obvious that these are not your human consumers trying to buy something from online store or read the social media posts. You need to use something better than that. And the best answer here is using the IPs from residential areas, from home internet providers, from mobile cell phone data providers, because if the server tries to block these IP addresses, they'll most likely shoot themselves in the foot, because lots of human users also come from these networks. These are the prime source IP addresses that your human consumers come from. You cannot just come and block them. And these IP addresses are not very cheap bulk, and you have to acquire them from the providers who do that. This is probably the main stepping stone for going into more commercial web scraping. You have to pay for these APIs, you have to pay for some other services, and that is where the cost of the data comes into play. If you are intending to sell the collected public data and find the correct consumer, you need to evaluate how much this data costs. For a simple setup, let's say 1,000 data points collected each from an individual HTML page, and you have to do this task each day for a month. What do you need to get this data? Well, you can use the turnkey approach and order this data from a commercial web scraping company. They will do everything by themselves and present you with a clean data sheet with all the values that you needed. If you wish to include some of your coding, you can use a specific scraping API, which you can build in your own script. It'll take care of most of the JavaScript and API challenges and checks for bots, bypass captchas, and present you a data point per each request. If you have your own scraper set up, you need to use residential IPs, which are also not very cheap. And if you have your own residential IPs, for example, you hacked a number of routers and use them for scraping, you still need something like a captcha solver to bypass the more sophisticated checks. And these guys charge per every completed request. So now you might wonder and ask me, George, why are you talking about money? This is a high-load conference. We're talking about technology here. Where does high-load come into play here? Well, the simple answer for that is that when your data costs less than this, you always have the guys have enough time, patience, and curiosity to experiment with their own DIY scraping setups, skipping all parts about business ethics or rate limiting or something like this. And the efforts that they are doing are often going out of control. Typical scraping activity on the production resource looks like this. You have slight increase in some of the metrics, requests per second, several load times. This stuff, of course, it's parasite traffic. It may be unpleasant, but it's still not really crucial. You might have more important tasks to deal with as a site reliability engineer or an application developer. So this might pass for a while. The difference between these and denial of service attacks is that the requests sent here are mostly legit. They are intended for the backend components serving them. And these attacks usually go on for a long time. Days, maybe weeks, maybe months, without interruption, if not dealt with, of course. But we're seeing more and more cases which look like this. Well, that's not pretty, isn't it? 20,000 requests per second for a sustained period of time. That would be a death sentence for most of the production servers. If not for the detection and mitigation, the server would go down in the first few seconds. So it's more like a layer 7 DDoS attack, but what is peculiar about it is that from what we've analyzed and from what we were able to retrieve, it was done by a primitive web scraping setup instead of a DDoS botnet. So it was just a number of Python script instances running the request library, just doing the GET requests from a number of residential proxy IP addresses. Nothing huge, nothing special, but they just put the pedal to the metal and made 20K requests per second. And we were seeing that on monthly basis before, but now it's more like a weekly basis. So the number of these cases grows, and it's what concerns me. And what concerns me even more, that the same can be achieved with a full-stack web scraper setup running a web browser, an orchestrator, with lots of legit characteristics about it, more difficult to mitigate, more resources taken to mitigate. But scaling is very easy for these guys now. And why are we even talking about browsers? By the way, that's the number of requests that we've done. Headless browsers, of course, you can choose from a variety of software here. You can run Firefox, you can run Safari, but we'll be mostly focusing on Chrome. And there are very obvious reasons why it is so. First of all, Chrome and Chromium is preferred by humans. This is the research done by W3C. 80% of users are still running Chrome and its derivatives, and you cannot go around it. And of course, when your task is to mimic the human user, you'll go not for some obscure, rarely seen solution, but instead for the most popular one. And that is what we see in our research. This is like the top 5 user agents, the bots that we blocked last month are using now. As you can see, all 5 of them are Chrome or Chrome related. So when running a web scraper, be it just a Python or Node.js or JavaScript without any browser imitation, you still will go for top 1 because it's the most popular one. And of course, using the full-scale Chrome browser, its headless variant, has also some other reasons. First of all, native interface presented for headless browser and different orchestration tools, which were originally built for Chrome. They are near perfect. They are very good. They have lots of features. They are easily extendable, and they are supported by very competent teams of engineers. First of all, back in the day, it was Phantom.js and Selenium, which required lots of effort to tune properly and resulted in some sophisticated setups. Now you have the Puppeteer, made by Google, extended by Google, intended for Google Chrome Headless, with lots of native functions built in. And you have the Playwright, which is one step ahead, done more or less by the same team, also supporting Firefox and other browsers. And also, one thing here, Playwright has native Python support. It has a native Python library, which is very pleasant. You don't need to learn Node.js like I had to back in the day. So that might be interesting for some of you. In addition to that, Chrome also has lots of extensions for no-code scraping. If you don't want to write your own scraping scripts, you can also use the ready ones, and there are plenty of them. For lazy people, this is the way to go. And the elephant in the room that I'd like to address here is that nowadays, the Chrome Headless resembles the human-operated browser very much. There is so little difference. So Chrome Headless, back in the day, as Google guys say, it was a separate code path in the Chrome engine. So it was like the same browser, but still a bit different. And these differences were the key things that it could be detected and by the bot detection solutions, by the DDoS protection solutions. Lots of these differences, you had to do something about them. Still, even with them, it was and still is very valuable because having roughly half of the page load time with Headless Chrome, because you don't need to load CSS, to load images, anything that can be rendered, you just don't need it. You can go straight for the data. And of course, CPU and memory, Chrome Headless is less intensive on these, so you can scale this setup pretty well. And now, it goes even further because starting with the version 1.12 of Chrome, the new headless mode is actually run by the same code as the headful one, as the full browser which renders the screen. So there are less differences here. Shout out here to Antoine Vastel, who I believe is a prime expert on this topic. He's done a lot of publications about headless Chrome and its detection, so I'll be referring his efforts and his work here. He's done a lot of inspection for the fingerprints for the new headless Chrome, and concluded that lots of things that had to be worked around before are now native to headless Chrome. For example, the plugin sections in the browser navigator property. It is fully fleshed out. It has all the default plugins that your freshly installed Chrome on a new machine, the same as a human-operated one. And I'd like to take your guesses. How did the plugin section look in the old headless Chrome? Any ideas? Exactly. It was an empty field. The plugins many times were empty, void, like prazno polje, as they say in Serbian. So you had to do something about this, because any check on you can run the JavaScript against this headless browser, like a JavaScript check on your website, check for the plugin section, see that it is empty or there is some garbage in there. Okay, you have your headless Chrome, just go away from here. Previously, the scrapers had to work around it by redefining the browser properties inside the configuration, or later Puppeteer supported these redefinition on the go. So you can just run your script, change some settings, add these sections to redefine the browser properties and objects, and you'll be fine. And you may wonder here, why cannot I just run a headful browser in parallel, take all of these properties listed in a good browser, and just copy and paste them, redefine them in a headless one? Well, technically you can, of course, but this can be detected as well. There are lots of ways to check whether the browser properties, which should be native, for example, to the Chrome engine, were redefined externally. And lots of bot detection solutions do that. In fact, this is the prime technique for JavaScript bot detection, by running all of these checks and seeing that some of them were made differently. For example, looking at the string representation of the property in the navigator object. If the toString result is different from the native one, they'll be obvious. Checking for parent objects and derivatives. Checking for the same values in different places, in different browser properties, and comparing them if they're still the same. Lots of things can lead to you being caught when using a headless browser. And this doesn't only amount to the exact properties. The things that bot hunters look for as well is your device and operation system fingerprint in addition to your browser, like checking for Windows properties if you presented yourself as an Android device with the browser. Of course, as the headless browser doesn't run anything rendered on the screen, you can also check for screen properties, the window size, the size of different objects inside the window of different elements, if they don't overlap, if they correspond well with the screen resolution. All of this information can also give up the tempering. This also goes for WebGL and Canvas, as nothing is really rendered in a headless browser. You need to stuff the correct-ish values into the corresponding properties to pass up as human. And of course, for some more sophisticated setups, you need also to track how human is doing anything on the screen, like touch screen inputs, mouse movements, and so on. Of course, this is nasty. This is resource consuming, but sometimes bot detectors have to resort to that. And the thing is, with new headless Chrome, all of these like 4 categories of techniques became less reliable. As lots of things are very similar now, the amount of false positive rates blocking good users because they look somewhat fishy has increased. And while scoring a user, while weighing in different opportunities, you have to put less belief, less weight into this stuff. And you have to mix in more of the underlying protocols and abstraction layers and fingerprint them as well, such as transmission control, segment data, fingerprinting, TOS, handshakes, cipher suits, the application layer protocol suits that we have now. All of them have been talked on this conference, HTTP2, HTTP3, the original one. They also can be fingerprinted to distinguish between different users. And when running, for example, the quick plus HTTP3 setup, if you terminate the connections on your side, you have lots of interesting data that you could pin to the exact user. So mixing up these fingerprinting technologies with the original JavaScript browser fingerprint can help you track bots and users better. And usually you have to feed this huge chunk of information about each user to your scoring algorithms and to your bot detection, like decision-making component, in order to actually pass someone's request or block it. So how prevalent is the headless browser scraping, in fact? Well, not really. Compared with the other scraping threats that we've seen, it is minuscule. Most of the scraping is still done with direct API calls because it is the most convenient and the cheapest way of web scraping. You don't need to load the page. You don't need to understand which data on this page you need and which you don't. If you can just load the JSON data with the API call. Also, it is in some cases when there is a mobile application, for example, it's not that easy to detect any bot shenanigans going on. Non-browser web page scraping, like using the Python or Node.js in order to do direct requests, load the page, and grab the data, parse it, put it in a spreadsheet. This is the old school way of scraping. It is still quite popular, but less and less because bot detection techniques, usually the first step they are doing are checking for this. And if you cannot run JavaScript, you'll probably not be able to grab any data at all. And headless and headless browsers comprise about 2% of the all load we've seen in the artificially generated traffic, and it's still there. And the reason why so many efforts are put into doing this and preventing this is because the targets that these types of scrapers choose are probably the most valuable. Their data is the most expensive, so they are ready to invest time and money into this. And this is why we do so many different mitigation techniques. We have to combine all of this fingerprinting and make it more and more unpleasant and intrusive for human users, is because these guys know what they're doing, and they know how to grab this data, and they know how to make money of it with also presenting some of the risks in terms of server load, performance, and business metrics. So this arms race is going on. It becomes more and more sophisticated. The share is not big, but it will grow for sure. So how does it concern you for your home application, let's say? If you have your own pet project, or maybe a startup running and dealing with publicly available data. For example, you publish geolocation, weather data, stock prices, something like this. Well, if your data is worth anything, there will be people trying to scrape it. Maybe, if they are not too greedy, it will not pose a big problem at the start, but it will grow on you in the future, because unlike DDoS attacks, which come and go, the scraping goes on and on. If you don't prevent it, they just become more and more intensive. And in order to dive into this rabbit hole, you need to start with studying the basic fingerprinting technologies. There is a project named Fingerprint.js, an open source project which is devoted to studying the browser fingerprints, its differences, and the techniques to detect any kind of tampering. Also, the Crypt.js fingerprinting browser fingerprinting library is also good. The problem with these guys is that most bot makers and scrapers use these as benchmarks for their challenge bypassing efforts. So first of all, they try to see if these things don't detect them. So in order to understand which techniques they apply to bypass, you can look no further than the plugin for Puppeteer, which is called Extra Stealth. This is the #1 most used headless browser scraping trick. It is very well supported by the scraping community. You can see lots of tips and tricks on how to bypass common JavaScript challenges. So if you wish to use this kind of technology for your home defense, you need to know what these guys can do in order to prevent it. The obvious thing here is that you have to have some kind of rate limiting on your site per IP address or per user. No one likes rate limiting. No one of us, I think, likes the rate limiting. But unfortunately, this is inevitable, because if you don't do any kind of rate limiting on your site, on your server side, your data will be scraped at the rate that you are allowing. And when the sky is the limit, your server won't thank you for additional 100 or 1,000 requests per second coming. As you can see, these cases are quite popular now. And of course, you need to track your users somehow. I'm talking about first-party tracking, of course. If a good user came to you and you checked them doing a JavaScript challenge or a CAPTCHA, you need some kind of a cookie or a token to let him come again, him or her come again, and not be presented with these checks again for some time. These tracking needs to be dynamic, so it needs to be pinned to the user device. Use some kind of combination of his her IP address, or maybe the device, the operation system, something that you can pin and distinguish this user with. And they need to be renewable and changed ever so often, because scrapers can just grab your cookies and use them from a human-operated browser and use them with their scraping setup. This is a very popular technique. And a good idea is to have some kind of a proof of work installed in there when generating these cookies, because this will also weed out the guys who are trying to pass as JavaScript compatible, but are not actually running any kind of JavaScript machine on their side. Sometimes you can just guess the exact cookie value for your user and create it inside your Python script without running any JavaScript sandbox. This is much cheaper. This is much cheaper than headless browsers, and a lot of guys are still doing that. So all of these things have something in common. Basically, this is a deterrent strategy instead of walling off against these threats. So you're trying to present yourself as a more annoying, more unpleasant target for the scrapers, in hopes that scrapers will find an easier prey, and if this data is available from someone else, they most likely switch their efforts towards them. This is what most guys are trying to do, and walling off from the scrapers completely is a task I haven't seen completed by anyone. So what is ahead of us? In the near future, the AI is playing a huge role in changing the landscape. Also, the cookieless setups and some changes in the cookie policies are also with us. I'd like to ask your opinion. What do you think? What's the AI's game in here? How the AI is affecting all of this stuff? Any ideas? Any opinions? Okay, more data. Any other ideas? Yeah, sort of. Well, okay, some other things I'd like to tell you is, first of all, of course, machine learning models, be it the image generation, the text generation, they not only need vast amounts of data, they need new actual data. Everything that we humans write, post to the internet, draw images, take pictures on our phones, create YouTube videos, all of this is collected, categorized, and parsed by AI right now, every day. And they need more and more of this data. So the only way to get these big data sets is, of course, data scraping. Ethical or unethical, it depends on the vendor. But still, it's happening and it's growing day by day. Also, one other thing about AI. First of all, most bot detection solutions nowadays are utilizing the scoring algorithms with trained models, which sift through all of this data, through all of these huge fingerprints, TCP, TLS, HTTPS, JavaScript fingerprints. Sometimes you need a lot of factors taken into account. And AI does the scoring quite well. The problem is that AI also gets good scores when trying to bypassing protection. So this doesn't get any better in the future. And about the cookieless setups, well, you probably have heard about Google trying to phase out the third-party cookies. They have already delayed it once, so there is no reason why they shouldn't delay it again. But still, mid-2024 is what they are aiming for. Removing third-party cookies is, of course, a biggest problem for online advertising and marketing, but a lot of bot detection solutions are also relied on site-to-site tracking, trying to pin the same bots on different websites. Well, Cloudflare used to use the site-to-site tracking cookies back in the day, but I think in 2021 they published the phase-out and let everyone know that they are no longer doing that. Well, having about 40% of internet traffic allows you to do that, but lots of other bot detectors don't have this luxury, so they have to rely on this technique. So they'll have to do something different. It will change the architecture, it will change the way the users will be fingerprinting. And all in all, the basic idea here is that with less site-to-site tracking for online marketing, for bot detectors, for everyone, there'll be more fingerprinting on each, there'll be more first-party fingerprinting on each individual website. It means more challenges, longer challenge completion, more captcha, even more capture, lots of not really pleasant things for human users as well. And the funniest part is that with all that in mind, your data in the future will still be scraped in new, inventive, clever methods. Maybe it will take some more resources to do that, but it will still be scraped. And there's nothing really unfortunate about that. This is the world we're living in. Let's embrace it. Thank you so much. I got some questions lined up for you with the answers. These are the most frequently asked, so check yourself against this table.
Hello, thank you for your talk. You've shown us the percentage of advanced bots that were, as far as I remember, 2% with browser and everything. And you told about that for some more costly data, it may be more advanced bots who comes from costly data.
Mm-hmm.
Do you have some statistics maybe with some anonymization of how percentage differs for some sites that are make more interest for bot owners?
Okay, So when we're talking about the top of the food chain of the bots, the more sophisticated setups, they usually don't even use the headless browsers. They use the full stack headful browsers with the screens, or even the mobile phone farms welded onto a single frame operated by the external automation. There are lots of ways to pass as human, which are more costly than what I have described. This is just the most common setup. And of course, again, the sky is the limit. You can have real humans doing the scraping. It doesn't cost too much. You can use a Mechanical Turk or Taloka from Yandex to do these simple jobs for data grabbing, lots of this stuff. So we don't really categorize the more sophisticated, we don't usually categorize more sophisticated bots into smaller categories because for us as a bot detection product, they look roughly the same. This has something to do with browser tampering. So this is like a browser bot. Headless or headful, not much difference. So I don't think we have this kind of statistic at hand because the mitigation technique is still the same.
Thank you.
Hi, and thank you for your presentation. Sorry for that question because it can be, I don't know, inappropriate, but I can't not ask it.
Okay.
So, did you heard about latest Twitter move to limit, requests per 600 per user?
Okay.
So,
The rate limiting in Twitter.
yeah, do you think it's a good move? It's a bad move? What else we could do? Because I think that basically was like really we didn't think much about it from my side of view. But I'm not a specialist. So what's your point of view about this decision?
Mm-hmm. Well, it might be good for Twitter, but it's surely bad for any human users, because, well. Now we know that Elon Musk knows about rate limiting. Well, a big step forward, like a big step towards the sophisticated bot detection techniques. First step is usually rate limiting. As I mentioned, you cannot live without rate limiting. At some point, you'll have to implement that. When you're as huge as Twitter, that will affect lots of people at the same time and cause a lot of negative backlash, right? But still, if they cannot run without it, this is the fact. For human users, it will cause additional limitations. It won't do much for the scrapers, I believe, because there are vastly more sophisticated techniques for bots to bypass rate limiting. It will make it a bit costly to scrape Twitter, but not by much. So it's a negative trend, but it's inevitable.
More questions, please. Comments? Please.
Any comments on Reddit situation? The same with as Twitter. I mean, the API walls and their decision to block getting data for natural language processing. Is it like? Is there anything good in that? Will it come to constructive things?
There are lots of conflicting opinions about that. Usually it's both good and bad for some categories of users. I have one of the questions fleshed out on this slide about the API. Is it okay to offer any kind of low-effort API to appease bots so they will not scrape your web pages? Well, generally the answer is no, because if you have an API available, the scrapers will use both web pages and API to grab the data twice as fast. And this is what happens with online stores. This is what is happening with Reddit. And any kind of step you take will be hurtful for the human users. So yes, it's a negative trend, and Reddit and Twitter had to face it with scaling of the scraper efforts. We are now in the stage when it is obvious to anyone.
Any more questions? Just a second. There you go.
Hi, maybe one little question. Are there any legal implication or regulations related to managing web bot activity?
If you cannot prove that it has like criminal motives for that, like password brute force or credential stuffing or misleading spam, in most jurisdictions, using bots for like web scraping is legal. And you cannot just easily ban this activity because it will hurt humans who look a bit fishy with privacy plugins and so on in their browsers, but it won't stop any kind of bots. They will just mimic a bit better. So all in all, any kind of legislative activity against bot usage is at best fruitless. And at worst, it is very hurtful to humans.
You can take my microphone, I guess.
Thanks a lot for your demonstration, how you fight with bots. But I don't understand how you distinguish how your approach works after you apply bot protection.
Can you please repeat approach? Which approach what?
When you apply new algorithms for protection from bots, how you distinguish which percent of bots will throw your wall?
You mean who is successful in bypassing the check?
Yeah.
The answer is there is no way. That is why they are bypassing. They are too good to be detected. This probably all security stuff has this thing in common. When the attack is successful, you only know because someone is hurt behind your defensive countermeasures. And usually, there are some ways to do the behavior analysis. When a bot is very persistent, he's good in bypassing your checks. He's doing all kind of, he's passing all the challenges, which are usually done on the first request done by the user, successfully. But they're persistent. They do the same thing every day. And you can do the behavior analysis in order to pin this very user and eventually prevent his activity, her activity. But this is the efficiency of this task is very low. I have to use human analytics. I have to sift through weeks of server logs in order to get this correct. And you still have risks of banning good users who are just a bit different from the others. So all in all, if you have not caught the bot at his or her first request, the task of catching them later is very tiresome.
Thank you, George. So who gets the prize for the best question so far?
Ooh, not an easy task.
Could you please wave if you asked a question to help George a little bit? Yes, 1, 2, 3, 4.
Okay, the question about the most sophisticated scrapers and the data cost, the one that I have not touched in this presentation, yeah, but it is surely very important.
Yes,
So,
thank you very much.
Thank you for the questions.
Thank you, George. Thank you for your talk.